This is a big deal, gerrymandering. Sorry. You know, what we talked about so far is kind of like how to do it. If I show you a map and I tell you, I want you to rig this so that this or that party has an advantage. That's what we've been doing so far. But in the real world, what is more important, at least in terms of like making rules about these things, is how to actually measure if a map that is being presented to you is unfair or not because of gerrymandering. This is an especially big deal because people all the time challenge the other party's versions of the maps. They say, no, that map is unfair because it's racist or because it's just unfair for some other reasons. And this usually ends up being argued in courts, and they need some kind of way to say to the court, this is not fair, or this is like a partisan gerrymander, or this is a racist gerrymander. There are actually specific like numerical ways that you can measure the fairness of these kinds of gerrymanders. And there's a few different ways to do it, and we're going to talk about some of them. So this is in the general category of how to detect gerrymandering. This, I suppose, for our society is a more useful skill. There's only a few people who are actually drawing the maps, and it's up to everybody else to figure out if those maps are fair or not. So how to detect. There's a few different ways to do it, like I said. What we're going to talk about today is a specific method called the efficiency gap. The efficiency gap. And it is kind of a numerical thing where you do a bunch of looking very closely at the districts and you come up with a number at the end where like if this number is 0, it's a percentage. And if the number is 0, that means it's like totally fair. If the number is a higher percentage, it means that the map is somehow skewed in favor of one or the other party. Anyway, it's called the efficiency gap, and it's commonly used in these kinds of court cases where people try to argue that this or that map is fair or unfair. And this is a great example, this picture here. So what you see in this picture, this is the state of Wisconsin, their state house. So this is not the representatives in the U.S. Congress, but within the states, every state has their own system of like local representatives. And this is the Wisconsin one. And this is the map that after the election in 2018. These are elections which happen every 2 years, and it hasn't happened yet in 22. And I wasn't able to find a good map for 2020, so I'm going with 2018 is what I meant to write. Sorry, that was the future. I did it again. 2018. All right. What you want to notice when you look at this picture, so the red zones are regions where the Republicans won, and the blue zones are where the Democrats won. And you can see some kind of unsurprising things. Most of the red zones are giant, like geographically speaking, very large, and most of the blue areas are smaller. That's because, as we all know, the Democrats tend to win in the cities and the Republicans tend to win in the country. This is just the way it is in American politics. And so that's why the Republican by area are much larger than the Democrats by area, but the populations are all roughly the same. Anyway, what you'll notice is the blue ones in this picture tend to be very dark blue, which means the Democrats won by a huge margin, whereas the Republican ones tend to be lighter reds, although some are dark reds, but most of them, I would say, are some kind of intermediate shade of red, whereas the blue areas, almost all of them are totally solid blue, all right? What this suggests, the map here suggests, the Democrats, and by the way, this map that they're using was drawn by Republicans, and you'll see why. This suggests that the Democrats have been packed and cracked. Because for the most part, the regions which are being won by the Democrats, it's like all Democrats in there. And the regions which are being won by Republicans are lesser majorities, like these sort of light red areas, all right? That suggests that the strategy was we're going to let the Democrats in those cities, we'll let them have their own districts for the somewhat. We'll give them districts where it's like all Democrats. But then everybody else we're going to win by making it so that those Democrats don't have enough majorities. Like right here, like you can especially see right here, we have super dark Democrat areas right next to very light Republican areas. This suggests that Democrats have been packed in here, but then some of them have been imported into these two areas in order to make a narrow victory for the Republicans. That allowed the Republicans to sort of take away a bunch of Democrats from these areas and join them in with these two regions. All right. This suggests, the picture suggests the Democrats have been packed and cracked. And actually, in this picture, the darkest blue ones, which are all of Madison, all of Milwaukee, well, almost all, and a bunch of others. If you look at the key here, those are actually unopposed. So the Republicans who created this map, they packed the Democrats, and then they didn't even run candidates in those areas. They say, you guys can have these ones, and we're not even going to compete at all. Most of the districts that were won by Democrats were unopposed, which, to me at least, suggests that the Republicans intended for those to be packed full of Democrats, and then they didn't even care to oppose them in those regions because it was a lost cause. All right. Anyway, let me tell you something about the numbers here of how this worked out. These are 2018 statistics here. So I will say statewide, 53% voted for Democrats and 45% voted for Republicans, and a few percent voted, for somebody else. And then, but Republicans won 63 out of 99 districts. This, I would say, is an extremely effective map in terms of screwing the Democrats, right? A majority of the people in this state actually wanted Democrats to win, but the Republicans, just because of the way the map is drawn, ended up getting 63 out of 99 of the representatives. All right, so very effective. Anyway, what's been done here is this kind of packing and cracking, and the efficiency gap is a specific numerical measurement which is supposed to measure the extent to which the districts have been packed. All right, so that's why I bring this example up. The efficiency gap, which I'm going to write as EG, the efficiency gap, I'll write it once more time all the way out. Measures packing. Really, specifically it measures packing. That is the extent to which some districts have just been filled with one party. All right. It has to, one way of looking at this picture, you might ask, what's the point of packing these districts? For instance, Madison, they put everybody in there, or maybe even like you can see these little guys. I don't know Wisconsin well enough to say what are these. They're probably small cities, I imagine. I don't know. But somehow, all the Democrats who live in this area, it seems they've been like concentrated right there. And then I'm sure there are other Democrats here, but they've been spread out across these other districts, which allow the Republicans to win the rest of it. Anyway, what's the point of doing that? I think one way to explain or describe why this is done is that you have loaded up this district 100% full of Democrats. Now, I don't know if that's actually true, but a lot of Democrats. They didn't even run a Republican in this district. So they have loaded up this particular district full of Democrats. If you think about it, the Democrats, you need 50% in order to win one of these districts. They're basically allowing the Democrats to take 100% here and giving them less than 50% in all the neighboring districts. Whereas, rather than taking that 100%, they could have taken some of those 100% and distributed them around here to win more. But they kind of packed them in there so that they would waste those votes. This is the basic idea behind the efficiency gap. it measures packing, I'm going to say, by counting what they call wasted votes. If you think about, if you really have a district which is something like 100% Democratic, about half of those people are kind of spinning their wheels. Like you only needed 50% to win the district, and then you just have, thousands of other people who also voted Democrat, but really their vote didn't make much of a difference. They could have been in a different district and made a difference, but they were stuck in the packed district. All right, this is what the efficiency gap is supposed to be measuring. So I'll tell you specifically what a wasted vote is. There's the real definition here. A wasted vote is one which doesn't contribute to the winner's win. All right? The idea is if you have a district which is like 100% Democratic, about half of those votes were wasted. They weren't really necessary, right? In order to win the district, you only need 50%, 51%, whatever. All the rest of them were kind of extra, which aren't doing the Democrats any good, especially. They already won the district. Those are called wasted votes. They are votes which don't contribute to the winner's win. So I'm going to be a little bit more specific here. Because, of course, there are people who vote for the winner, and there are also people who vote for the loser. So the way that you count up wasted votes is any vote for the loser counts as wasted. Just because if you don't vote for the winner, then your vote does not contribute to the winner's win. That's the definition of wasted, is a vote which does not contribute to the win. If you vote for the loser, obviously you are not contributing to the win. And then any vote for the winner beyond the winning threshold is also wasted. Right? In order to win these districts, you need to get a certain amount. If you're getting a lot of extra, those are wasted votes also. So any vote for the winner, which is beyond what they need to win, that also counts as wasted. All right, so in a mostly, let's just try some quick examples here. In a district with, let's say, 100 voters, say they vote like, let's just say Democrats and Republicans. Let's say if there's 100 voters in a district and the Democrats voted for, or 47 voted for the Democrat and 53 voted for the Republicans, how many votes, how many wasted votes are there, and by whom? Well, I already said any vote for the loser is wasted, so all of these are wasted. All these are wasted. And how many Republican votes are wasted? Well, in this example, there are 100 voters. How many do you need to win? I suppose it would be 51. 50 would be a tie. I don't want to do ties, so you would need 51. Here, I'm going to say 2 of these are wasted. All right, that's because you need 51 to win, and they got 2 extra. So those 2 extra are the 2 wasted votes from the Republicans. All right? And in this case, the Democrats have wasted far more, but that's to be expected because they lost. All the votes for the loser are wasted. All right? But check it out. How about, what if it's more like, let's say the Democrats voted something like 97% and the Republicans voted 3%. This is like one of those deep blue packed districts. What are the wasted votes in this case? In this case, all 3, so the Democrat will win, And so the Republicans are the losers here. So these 3 are wasted. All 3 are wasted. That's because the Democrats won, right? And of the 97, how many of those are wasted? Well, you need 51 to win. So I guess 46 would be wasted, right? That's 46 extra votes here. All right. This is how it goes. The moral of the story, if you look at this here, so in both examples, you have sort of one party is wasting a lot and the other party is wasting not a lot. Like here, the Democrats wasted 47 and the Republicans only wasted 2. But what you see here is in an even district, in a close district, the winner wastes a little bit and the loser wastes a lot. Whereas in a packed district, the winner wastes a lot and the loser wastes only a little bit. That means it's bad to be in a packed district. It results in lots of wasted votes, even if you win. All right? That's the moral of the story here. So in a packed district, the winner wastes a lot. That means it is beneficial to pack your opponents. You're going to make them waste a lot of votes in their own districts. If you pack them into their own districts, they're going to win those districts, but they're going to waste a lot of votes while doing so. All right? And if you keep your own districts a little more even, then you will waste far fewer votes. This is the idea. All right? In a packed district, the winner wastes a lot. So we screw our opponents by packing them. Yes, it makes them win a few districts, but it also makes them waste a lot of their votes that could have been spent winning other districts. All right. Let's talk specifically about how we compute the efficiency gap. I said it was like a numerical thing here. What we're going to do is the efficiency gap is computed by just counting up how many wasted votes are assigned to each party. If the Democrats waste far more votes than the Republicans, then that's a problem, and that's the way that the efficiency gap works. The efficiency gap is computed by counting wasted votes from each party. And then comparing, which party is wasting more votes than the other. That's the idea behind the efficiency gap. All right? So I have a very simple example first, and then we can talk about some more fancy ones. I'm going to do an example on this grid here. I hope that you still have a handout with this picture on it. If not, I'm only just going to do this one, so it's not a big deal if you don't have this. I would like to draw these particular districts. I don't know if I ever drew exactly these before when we had this picture last. Like so. All right, I have here 5 districts, and I'm going to give them numbers. This is District 1, 2, 3, 4, and 5. All right. And I want to measure the efficiency gap here is done by figuring out which party has wasted votes in various districts. All right, so let's find the EG. I know I haven't described exactly how to do this, but it's a bit of a process. It's like most of the things we do. It's not really very mathematically complicated. It's just you have to go through and do it right. How we do it? Here's what I'm going to do. So first of all, we have the 5 districts. I'm going to make a big chart here. The district is 1, 2, 3, 4, 5. I'm going to try to do this without scrolling the picture away. All right. Now what we're going to do is count up how many votes are wasted by each party. Here we have the darks and the lights. So just to like get us going on the chart here. In District 1, I'm going to write down how many votes there were. For the darks, there were 4, and for the lights, there were 6. This is just counting up the votes in each district. In District 2 was also 4 and 6. District 3 was 2 darks and 8 lights, right? Etc. I'll fill in the rest of the rows just so that I don't have to scroll now. I'll do those later, all right? This is the beginnings of the chart. Now, the next column I'm going to write is just the total number of voters in each district, which in this example, the total is always 10, all right? Because it is. That's how I made this example up. In a more realistic example, these totals might be slightly different from one district to another, but these are the total number of voters in each district. If you like, you could just add the D's plus the L's. You get 10 every time, all right? And then I would also like to put on my chart here the threshold. That is how many votes you need to win. And this you figure out by looking at the total, which is 10. How many do we need to win? To win? What do you say? Out of 10. Yeah? 6, right. If you get 5, that's a tie. In order to win, you need 6. So the threshold, is always half of the total plus 1. If it's if the total was even, you go half and then plus 1. If the total was odd, you go half and then round it up, right? And it's the same in every district. This is kind of a simple example because all the districts are exactly the same size. The thresholds are always the same. All right? And then we're going to count. Actually, here's the important part here is I'm going to call these D wasted and L wasted. In that district, how many votes did the D's waste? How many votes did the L's waste? Maybe to help me remember here, I'll just sort of circle these L's. I'm circling those L's because they won in those districts. Now, some of the districts were won by the D's, but I would just circling the winner each time, all right? And now you need to count how many votes were wasted. Remember what I said about the wasted votes? Any votes for the loser are automatically wasted. So in this first row here, the Democrats wasted, or the dark ones wasted 4, right? Because they were voting for the loser. The D's lost in the first one. And then how many votes for the L's were wasted? This would be any votes beyond the threshold, which in this case is 0, because the amount they needed to win was 6, and that's exactly what they got was 6. So no waste for the L's in the first row. But all the D's were wasted because they lost. All right? And we're just going to do this for each of these rows here. The second row is exactly the same because all the numbers are the same. The D's wasted 4, the L's wasted 0. What do you say on the third row there? How many for the D's wasted? 2. Yeah, because they voted for the loser, so their votes are automatically wasted. And how many for the L's? Also 2. This is how many they voted over and above the threshold. The threshold is 6. They got 8. That's 2 extra. So the L's wasted 2 votes on that. All right, can we fill in the rest of the chart here? I didn't want to scroll away, but now I don't mind because I can still see everything. So the 4 actually has 0 and 10. And the L's 1 in region 4. And region 5 has 10 and 0, right? And the D's 1 there. Those are both packed. Okay, anyway, the total is still 10 each time, and the threshold is still 6 each time. In District 4, the D's wasted 0, right? They voted for the loser, but actually they had 0 votes anyway. So all votes for the loser count as wasted, but there were 0 of them. How many are wasted for the L's? They got 10 votes. The threshold was 6. That's 4 extra. Those were wasted. So the L's got 4 wasted votes. And then similarly, the bottom row should be D's waste 4 and the L's waste 0. Same scenario, but backwards. Yeah?
If you look at it overall, when you count up, since the last column is the only column that the darks won, so that wouldn't it be all of their
In the last row?
comparing it to everything else,
Oh, you mean because overall the lights won more than the darks? Yeah, that's, we don't think about that. I mean, the result, the overall result in terms of the number of districts is that we got 4 lights and 1 dark, right? But that doesn't mean that it doesn't mean the darks get nothing. So it's not like this one district is wasted. They still get that district. So everything is done per district. You don't really look at the overall outcome. Yeah, thanks for that question. Okay, anyway, we have basically done the work so far. Now it's just to summarize the answer. Like I said, the efficiency gap is one specific number, and it involves counting up and comparing the amount wasted by the D's versus the amount wasted by the L's. And you can see in this case, the D's have wasted a lot more, which means this map is advantageous to the L's. But anyway, the way specifically that we count these numbers up is I'm going to make totals on these 2 columns, because you have to count up in total. The L's wasted 6, right? And the D's wasted, whatever that is, I think 14. So I'm adding those up here, right? And then the efficiency gap is written as a percentage where the denominator is the total number of voters. So we're also going to add up this, which is going to be 50, right? That's the overall total number of voters. And out of those 50 votes, 14 of them were wasted by Democrats and 6 of them were wasted by the darks and the lights, not Democrats. I was going to say, I don't know what I call the L's. If I call the D's Democrats. All right, so my final answer, this is just how you say the answer. We say the efficiency gap here is, you write it as a fraction with the denominator 50, and the numerator is the difference. You subtract the different votes wasted by one party versus the other. So up top, it's going to go 14 minus 6, all right? And that difference is 8, right? That means the Democrats, or the D's, wasted 8 more votes than the L did. That's the point of this whole thing. The D's wasted 8 more votes than the L's. And this, as a fraction, you can divide this as 0.16, which if you want a percentage, you can say 16%. And we say this is in favor of the L's. So the efficiency gap actually, it consists of a number, and then you also say who is being benefited here. It's in favor of the L's. This is because the D's had more wasted. And so we say that this map is advantageous to the L's because the D's had more wasted. The efficiency gap of 16%. All right. Any questions about that? It's not, like I said before, I think it's not really hard. You just have to know what to do and do it. So I got one for you to try on a handout here. I have 2 maps, and I would like you to try to find the efficiency gap for each one. What you're going to see here is actually the same map divided up in 2 different ways. And the first way is more kind of natural division of the map, and the second way is a packed and cracked version. So when you do the efficiency gap, you should find that there are far more wasted votes in the second picture than the packed and cracked. So what you need to do is make a chart just like this one here. There are 4 districts. This is 2 separate problems, right? So let's say do the one on top first. I don't know if you can fit it on this piece of paper. You might want to make your chart on your own paper. And then do the same thing for the chart on the bottom. And while you're doing this, I'm going to hand out, I said I printed out the homework assignment. I will do that. If your deadbeat friends aren't here, you want to pick one up for them, that's fine too. Just let me know. 0. Yeah. Okay. That means it's like totally fair. I saw most people had finished the first one. That's great. You should have got 0 for the first one. You did? Good job. That means nobody's wasting any more than anybody else. And so, in terms of the efficiency gap, the first one is like totally fair. If you do the second one, you should not get 0. So yeah, remember every vote for a loser. So you have to look at this one. All
Yes.
How many losers? That would be extra.
It's bigger number. I still got it. Yeah.
All right? Yeah. Oh, yes. Doing good? I'll give you 2 more minutes. The second one, I got 18 out of 64. You got that? You got.
What's
Yeah, the threshold.
that's this one?
Yeah, threshold is really this.
You said divided by
Alright.
Is that level total?
You doing good? Yeah.
So like this one just goes the box is 60.
All right.
One with 9, you need that. So all of this is like
Still good? You guys still doing okay?
we figure out which votes are like, I don't get
The
it.
wasted,
Yeah,
yeah,
I
that's the
do.
important part. The tricky part. It's like the only. Look at, so first of all, any vote for the loser counts as wasted. So in the first district, first you have to decide the who's are the winners.
Yeah.
First district. That means all of these L's are wasted. Not for 7. It's all those individuals are automatic. And then, for the winner, any votes beyond the threshold are wasted. So it's like how many extra. Okay. I'm going to write down my chart for the second one so we can chat about it. Actually, I wanted to. Yeah, that's fine. All right, maybe we can talk about the second one altogether. I know some of you haven't finished yet. That's fine. This could require sort of careful looking at the dots, which can take a while, depending on how careful you are. When you count up the districts, these are the amounts that I got when I counted up the dots in each district. And let's talk about the wasted. This is really the important part here, and the part that's easiest to mess up. In the first district, I think, first of all, who won? The D's won because it was 14 versus 2. That means every vote for the loser counts as wasted. So these 2 for the L are wasted, both of them. And then every vote for the winner that's over and above the threshold counts as wasted. So here, the winner's got 14. The threshold was 9. That was 5 extra. And so we have 5 wasted for the D's right there. I hope this is what you did. It's a little tricky. I mean, you just have to remember how to think it through. The second line is 7 and 9. Actually, that's similar to the districts from the earlier one. The 9 is the winner. That means all 7 of the loser votes are wasted, and 0 wasted for the winner because the threshold was 9 and they hit 9 exactly. All right, on this line, 6 and 10. The 10 is the winner, which means all 6 for the loser were wasted. And then the winner got 1 extra, right? They needed 9, but they got 10. So that's 1 wasted for the L's. And then in the last line, the 5 and the 10, the 5 and the 11. The 11 is the winner, means all 5 are wasted for the darks, and 2 for this one, right? 11 is 2 beyond the threshold. You can see, I mean, just looking vaguely, you can tell the D's wasted far more than the L's did. But specifically, how many more? You know, you go through adding all this stuff up. I got 5 here when I total that. This one I added up and I got 23. And the total number of voters is 64. So my final answer, you always do, you look at these 2 numbers, you do the bigger one minus the smaller one, and that's the numerator of your fraction. So the EG is 23 minus 5 over 64. That's 18 over 64. In favor of, who is it in favor of here? The D's or the L's? Show me the hand signal. I don't know. I see some people doing this. The L's. In favor of the L's. That's because the D's wasted more. So this is advantageous to the L's. All right. As a percentage, if you plug that into your calculator, I got 28%. All right. In favor of the L's. This is how you can analyze a map and try to tell if it's been packed. If it's been packed, you're going to see a lot more wasted votes by one party versus the other. That's the idea behind the efficiency gap. I wanted to do one real-world example. We got 8 minutes left. I think that's enough time. Let's try. I want to look at the state of Connecticut, U.S. House Representatives in the latest election, which was in 2020. There's going to be another election this year, but this is the last one that happened. Remember, there are 5 districts in the state of Connecticut for the Congress, and they are currently all occupied by Democrats. Our representative is the great Jim Himes. I don't know anything about Jim Himes. I think I said that already. I follow him on Twitter. He's not especially fascinating person to follow on Twitter. Anyway, I'm going to tell you, you don't really need to look at the map. All you need to know is what the votes were in each of the districts. So I'm going to tell you Democrats and Republicans, and these are votes in thousands. So, unfortunately, you're just going to have to copy my chart for now. The District 1, Democrats got 223,000 votes. Republicans got 122,000. District 2 was 218 to 140. District 3 was 203 to 138. District 4 was 224 to 131. And District 5 was 192 to 152. All right? That much, if you're doing a problem like this, somebody basically just has to tell you those numbers. But then you can do the rest of the chart yourself. All right? So, the next column is the total, right? Now, in our examples, the total was always the same. But in the real world, every district is meant to be roughly the same, but they're not going to be exactly the same. Even if you make them the same population, people don't always show up to vote or whatever. The number of votes in each district is always going to be different. So, what I got to do here is actually figure out the total each time, and you can tell that by adding these two numbers together. With these numbers, you can use a calculator if you want to. It's not really hard, but I would use a calculator because I'm likely to mess it up. The total here is 223 plus 122 is 345. 218 plus 140, that adds to 358. I did this already on my paper to make sure I didn't mess it up. 203 plus 138 is 341. It's so humiliating to mess it up. I'm used to it. 224 plus 131 is 355. And then 192 plus 152 is 344. All right, those are the total in each district. Like I said, the districts are designed to have equal populations, but you never know who's actually going to show up and vote, so they're not going to be exactly equal when you count the votes. All right, that means actually the thresholds each time are going to be slightly different. All right, each time the threshold is half of the total, and perhaps plus 1 if you need to round it up or whatever. So when the total is 345, half of that is 172.5, which rounds up to 173. This also, I would suggest you use a calculator to do these. 358, the threshold is 179. Each time I'm dividing by 2 and then either adding 1 or rounding it up. 341, the total is 171. 355, the total is 178. 354, the total is, or 344, the total is 172. The total, I said total when I should have said threshold several times. Sorry about that. You know what I'm doing. All right. Finally, we get to the good part, which is counting up the wasted votes. All right. This you have to think, I guess, slightly. Maybe we should decide who was the winner in each of the districts. Well, we already know the Democrats won every time. That's just the way it goes in Connecticut these days. So, yes?
Shouldn't the threshold for District 5 be 173? Because 172 is half.
I think you're right. I messed it up even when I used a calculator, apparently. Thank you. And maybe this one's wrong too. If you divide this by 2, I think I was dividing by 2 but forgot to add 1. Oh, I'm so humiliated. I knew it. I knew how this would feel. So this one should have been 180, and this one should have been 173. Thank you for that. I forgot to add 1 on the even ones. The odd ones I rounded up correctly, I believe, but you got to add 1 on the even ones. Practically speaking, that won't change your answers. It will change them very slightly. Anyway, can we finish this off in the remaining 3 minutes? the D's won every time. That means every R vote is always wasted. So in this example, I can just copy all these R's where the R wasted because the R's lost every time. So 122, then 140, then 138, then 131, and then 152, right? How about the D's wasted? This would be how many extra did they get beyond the threshold? And we're going to have to subtract here. The D's got 223. The threshold was 173. How many extra was that? I think 50. Because you subtract 223 minus 173 is 50. Again, if you're doing this, I would expect you to use a calculator. I wouldn't give you one like this on our tests because it's just a pain to do the numbers. 218, so the next row, I'm going to go 218 minus 180. That's how many extra they got there. That would be 38. The next row, 203 minus 171. That would be 32. The next row, 224 minus 178 is 46. And the last one, 192 minus 173 is 19, I think. That was the one I messed up before. I'm trying to do it in my head this time. All right. What do we do next? We got 2 minutes remaining. I think we can handle it. What comes next? Add them up. Yeah. Find the totals in the wasted columns and also the total in the total column. So add up all the R wasted. Those, I did this ahead of time, add up to 683. And the D's wasted adds up to, I believe, 184. I'm trying to compensate for my earlier errors. I think it adds up to 184. And the totals, if you add those totals up, you get 1743. And now we are ready to say our final answer. Remember, you subtract these two things, the bigger minus the smaller, and the numerator, and then this number, the total is the denominator. So the efficiency gap is 683 minus 184 divided by 1743. This, I did the numbers ahead of time, although it's a little bit different from what I did before. I believe this is 499 over 1743, which is around 30%. It's more like 28%, I think. Anyway, you should say in favor of, who's benefiting here? The D's or the R's? Somebody shout it out.
D's.
The D's, yeah, because the R's have more wasted, right? The D's have less wasted. So this is in favor of the D's. All right. See you next time.